This is section 8.11. In section 8.11, we now talk about syn dihydroxylation. 8.10 dealt with anti-dihydroxylation, and so the opposite of that would be syn dihydroxylation. So in these reactions, typically, you have some alkene, and you treat the alkene with catalytic amounts of osmium tetroxide plus a peroxy alcohol, or a peroxide, in one step. And in the second step, you then treat this material, this osmium alkoxide that you generate, or this osmium intermediate, with a mild reducing agent such as sodium sulfite or sodium bisulfite to give the product you see here, which is dihydroxylation, but this time syn addition. Remember, syn means same face, which means you have to both have wedges or both have dashes. In this case, I'm showing you the both having wedges enantiomer. And the mechanism of this reaction is fairly straightforward. Upon reacting the osmium with the alkene, you generate, which is shown here, you have a type of concerted one-step reaction to make this bridged osmium alkene complex. And this actually can be isolated and is fairly stable. Osmium will happily share 2 oxygens with this carbon-based alkene. And then once you generate that material, then you treat it with our mild reducing agent, sulfite or bisulfite, to make the product of syn addition here, as we're showing it. Similarly, if you don't want to use osmium, which is super expensive and really toxic, you can use potassium permanganate and base, like sodium hydroxide, as long as it's very cold, and you'll also get the syn addition product. However, this reaction is a lot more difficult to run because potassium permanganate, as you'll learn next semester, is a very good oxidizing agent for alcohols. So you could maybe make this compound this way, but maybe it wouldn't be the most stable. So in general, in syn dihydroxylation, the osmium tetroxide way is actually the best way, but the osmium tetroxide itself is super toxic and expensive. So we find, as chemists, new ways to do reactions, such as with this potassium permanganate. However, finding a new way to do a reaction, as with anything in life, has its own drawbacks. And so sometimes we live with those drawbacks, and sometimes we go with the more expensive, more toxic option. But these are the 2 ways that are fairly well established to do syn dihydroxylation. And this was section 8.11.